Okay, good evening, Professor David J. De Los Reyes. Okay, it's August 27 or 26. It's not yet August 27. It's still August 26. My long video format discussion for the session will be college algebra, and this will now be the continuation of the last topic, which was logarithmic and exponential functions. For tonight, I will be discussing the graphs of exponential functions. We don't have to make any calculations under the graph, but I just want to show you what is the graph of an exponential function. Okay, let's proceed. The subject matter for this evening, a continuation of my long video format discussion, college algebra, and this will now be lesson number 44. And the title of the topic is graphs of exponential functions. Graphs. Number one, if we are given the exponential equation y equal to a raised to x, okay, this should be the graph. We plot the graph in the so-called Cartesian coordinate system, meaning we have the x-axis and this is the y-axis, because it seems we are given y as a function of x. So if we are given y as a function of x, we are on the so-called Cartesian coordinate system. To plot this graph, actually, it's not a very long, what they call this process. The number one step is just to solve for the x and y intercepts if there are any. What are the x and y intercepts? Just locate the point where the curve passes through the y-axis or x-axis if there are any. Okay, let's try to find the x-intercepts. Like in the plotting of the graph of a straight line, if we know where the straight line passes through the y-axis and x-axis, okay, just connect the 2 points and that will be a straight line. But for this y equal to e to the x, it's not even a straight line. It is an exponential equation. Okay, it varies. So to compute for the y-intercept and x-intercept, if there are any, we will bring out the equation y equal to ex. Right? When x is zero, okay, we are looking for the point where the curve passes through the y-axis. So when x is 0, we are on the y-axis, right? So when x is 0, the value of y will be y equal to e raised to 0 power. And any number raised to 0 power is actually 1. So when x is 0, y is 1. So the coordinates of the y-intercept will be at the location 0 and 1. So when x is 0, y is 1. This height here is 1, this height. So this point here, okay, this curve here passes through the y-axis at this location here, at the location 0 and 1. Okay? Next one. When y is equal to 0, we are looking for the location of the curve where it passes the x-axis. So when x is 0, we are along the x-axis, right? When y is 0, okay, we reverse this, right? X 0 here, the first one, next one will be y equal to 0. So when y is equal to 0 to this equation, 0 should be equal to e to the x. Okay, let's try to compute for x. To compute for x, the x is actually on the exponent. So to bring down x, we use the laws of logarithm for exponent, right? So take the logarithm of both sides. the logarithm of 0, common logarithm, we don't have the base, equal to the logarithm of e to the x can be written as x, the logarithm of a. So x now will be the logarithm of 0 with the base of 10 over the logarithm of a. Okay, we do not know the value of a for the meantime with the base of 10. But we got a problem here. Because if we try to take the logarithm, okay, of 0, this will be undefined. Right? Error. It is error. So, if you place 0 here, take the common logarithm, it is an error. We do not have any value over here. For the value of x, we do not have any value. It is undefined. So, if it is undefined, the curve does not touch the, what you call this, does not cross the so-called x-axis. So, I place it here, the curve then cross the x-axis. We do not have any x-intercept. So, how do we know that the curve goes up and they should be to the left, approaching the x-axis? Okay? How do we know? It is something like this. If we place x to be equal to infinity, okay, and here, what will happen? Y should be equal to a raised to infinity. Infinity is a very, very big number, right? Maybe a trillion, okay, a trillion, something like that. But this is a very big number. Very big number. So meaning to say, I shut off my alarm. Okay. Meaning to say, as we increase the value of x from 0 going to infinity to the right, the value of y will approach infinity. So it goes up. So as x moves to the right, the value of y keep going up. That's the meaning of this. Okay? So the curve should be going up like this. Right? As we increase the value of x, the value of y always go up, approaching the value of infinity. Infinity is a very big number, right? So the graph should be something like this. Okay? How about the left side? You can do it like this. If x approaches negative infinity, meaning we are going to the left. Okay? Negative infinity is a very, very small number. So if you place the value y equal to a raised to negative infinity, what will happen? Okay? A raised to negative infinity is a very, very small number. But it will not approach the value 0. So, meaning to say, as the value of x moves from 0 to negative 1, negative 2, negative 3, the value of x keep going smaller and smaller, but it does not approach the value 0. So, in here, this portion of the graph here does not touch the x-axis. So, it seems the x-axis is actually a tangent line to this curve. That's why we call this one the horizontal asymptote. If the curve does not touch the x-axis, okay, because it seems the x-axis is a tangent line to this curve here, okay, we call this line here a horizontal asymptote. Okay, so meaning to say, from 0 to negative 1, negative 2, till a very small value, this value of y here is approaching 0, but it does not go to the value 0. Okay? So this one here, the curve here does not touch the x-axis. Okay? So it will be something like this. They are tangent to each other. Okay? So the curve of y equal to e to the x will be this. This is going up, and this is almost approaching zero, but it does not go to zero, approaching zero. Okay, as the value of x move to the left, okay, the value of x will be -1, -2. The value of y will approach the value 0. It's very small, but it does not approach the value 0. That's why this x-axis here is referred to as the so-called horizontal asymptote. The curve and the x-axis does not touch each other. They are just tangent line to each other. Okay? Okay? There is a gap in between them. Okay? So the graph of y equal to the x will be this one here. Okay? Next one. The graph of y equal to e to the x. This should be a special case. Actually, the second one is actually emanates from the first one. That is, when the value of a is equal to e. Right? This e here got a significance for those who are studying electrical engineering. Because in the sub-calculations or for the parabolic curves like this, okay, we are to use this e to the x here. Later on, we will be solving a problem under the so-called hyperbolic, and hyperbolic involves e to the x. Okay? And what will be the graph of y equal to the e to the x? I think the graph will be the same, right? We compute, am I still on camera? We compute for the intercepts. So for the equation y equal to e to the x, when x is 0, y will be e to the 0, and e to the 0 is 1. So again, the curve y equal to the e to the x crosses the y-axis still at 0 and 1. Same as the other one, 0 and 1. And how do we know that this curve goes up? It is same as from the previous one, but I could show you that as x moves from 0 to the right, okay, we could say that the value of y is actually going up very rapidly. Okay, going up very rapidly. It is something like this. Okay, let's solve first for the x-intercept. When y is 0, okay, the value of x will be 0. We place y to be 0 here. 0 equal to e to the x. Again, if the value of x is on the exponent, right? So we bring it down by using logarithm. We use natural logarithm for the meantime. So take the natural logarithm of this. Natural logarithm of 0, it should be x, natural logarithm of e. And the natural logarithm of e is actually 1. So x now will be the natural logarithm of 0. But natural logarithm of 0 is actually undefined. Okay, if you put it on the calculator, okay, you take the natural logarithm, it is an error, meaning even the calculator cannot compute for it. It is undefined. It does not exist. So meaning to say, this graph here, y equal to e to the x, did not cross the x-axis. Okay? How do we know the graph to the right of the y-axis? It's like this. For the value y equal to e to the x, to be accurate, okay, we assume the value of x equal to 2 for the meantime. Y now will be e squared, the value of y will be 7.4. So when x is equal to 2, y is 7.4, this point here. Right? So when x is equal to 4, y will be e to the 4th. E to the 4th will be 54.6. So when x is equal to 4, this one here, y is 54.6. Right? So when x is equal to 8, y will be e to the 8 by using this equation here. And the value of e to the 8, that will already be a very big value, 2981. So from 54.6, it goes up to 2981. It goes up exponentially, okay? When x is equal to 16, y will be equal to e to the 16, E is 2.718 raised to the 16th power. That's a very big number. And this is almost 8 million. So when x is equal to 16, right, the value of y is almost 8 million. It goes up. So if we try to connect the points, it should be this. Okay? That's the curve. That's the exact curve. Right? So for any point on the graph, just put a value of x and you could compute for y and you can see that the graph is going up. It goes up exponentially. Okay? How about the other one? The other one will be the reverse. Because when x is equal to negative 2 is here. Okay? Negative 2. Negative 2. The value of y will be this. 0.135. When x is equal to negative 4, it is this. Okay? This value here is actually 0.0183. It's almost going to 0. It's going lesser. As the value of x moves to the left, the value of y is actually decreasing. Okay? So when x is equal to negative 8, over here, negative 8, the value of y is 0.003. It's almost 0 already. 0.003. And when x is equal to negative 16 maybe here, the value of y is, it's very small already, but it does not approach the value 0. It is 0.125 of a million. It's almost 0 already over here. Okay, it's almost 0, but it does not go to the value 0. So actually the x-axis is still considered a horizontal asymptote. So the significance of this, as the value of x move from 0 to negative 2, negative 4, negative 8, and negative 16, the value of x actually keep decreasing very rapidly, but it does not approach the value 0. It's almost 0, but it is not 0. So actually this curve here and this horizontal axis actually are tangent to each other. Okay, so the graph is this one. You notice this one, guys? you notice these vertical lines? It's the San Francisco Bridge. Right? The cable supporting the San Francisco Bridge. That's why in the computation of the so-called sub-calculations for the San Francisco Bridge, okay, we need to use this exponential equation. Okay? Okay, that's it, guys. The curve of a to the x will be this one here, and the curve of e to the x, the value of e here now is 2.718. This is approximately 2.72. Okay, and the graph of this is still similar to this, but to show you that the graph is actually going upward, we assume values, and we could say that the values, okay, increases from 7.4 to 54.6 to 2981 to 8 million in just a matter of 16 movements. Okay, so when this is infinity, this goes up to infinity. Okay, these are the cables supporting the San Francisco Bridge. Okay, this was the cable, right? So if you want to compute for the tension at any point on the cable, we could do it. That is electrically speaking, because this is the work of electrical engineers, you know. So exponential functions is actually very important in the so-called sum calculations of cables. Okay, that's it, guys. So for those of you who are studying college algebra, this is for you guys. If you want to subscribe to my channel is at youtube.com/@prof.dvj.de. If you want to share it, please click share, okay? This is just graph. At least we are still studying algebra and we know the graph of an exponential function. Okay, good evening from Los Angeles, Professor DVJ de los Reyes.